Hello there. We are embarking on essentially the meat of what Calc 2 is all about. And I've brought it up a couple of times in class, and I'm going to show you some examples of where we are headed. But before then, talk about my lesson today. So the lesson today is about sequences, which you did in Algebra 2. You probably did a little bit in Pre-Cal. And I make a note right here with sequences that there aren't going to be really any questions asked about this topic in particular. Um, the topic of sequences converging or diverging, meaning if you would list out the terms of a sequence, is it converging to an actual value? That leads to series convergence divergence, which is really what this chapter is about, is does a series converge or diverge? And so just to show you, a few examples in the book of what we're doing, you notice the directions all right here. It says determine the convergence or divergence of the series. Determine the convergence or divergence of the series. And it's just all about infinite series. Notice the top thing is always infinity. You're going to be adding infinitely many things together. And is it approaching a value? So that is what we are going to be doing. But before we can talk about that, we have to talk about sequences, because a series is just adding the terms of a sequence together. So to remind you in general, some of the more basic stuff, it says list the four terms of the sequence right here. So a sub n is going to be standing for a particular sequence. And if you want to find the first term, well, that means we're looking for a sub 1. So we're just going to plug 1 in for n, and we get our first term to be 2. And then we plug 2 in for n, and we get 5. And then we plug 3 in for n, and we get 10. And then we plug 4 in for n, and we get 17. So the first four terms of this sequence would be 2, 5, 10, 17. Okay. Next one, same thing. Plug 1 in for n. So we get negative 1 to the first power, so negative 1, and then 3 on bottom. So negative 1/3 is going to be the first term. Plug 2 in for n. So now we're going to get positive 1 over 4. And then plug 3 in for n. And we get negative 1 over 5. And then plug 4 in for n. Positive 1/6. So the reason I have this is because a lot of times, I mentioned how with series convergence, divergence, we're going to have a lot of different tests to determine if a series converges or diverges. And one of those tests we're going to come across is called an alternating series test, in which the terms alternate, positive, negative, and we'll be able to determine if that series converges or diverges. But bottom line, if you notice that, part of your fraction or part of your term is, this negative 1 raised to the nth power, or example down here, negative 1 to the n plus first power, then that basically tells you have an alternating sequence, or when we get to series, an alternating series. The terms are going to go positive, negative, or negative, positive, depending on the first one. So I just wanted to point that out right there. Okay, let's talk about a sequence converging or diverging and what that means and how we find out. So it says let L be a real number. The limit of a sequence, meaning if we expand all the terms out, is written like this. And notice it says n going to infinity. So we want to see, plugging in not just like the 100th term, but like the infinitieth term, which is just conceptual, but like getting way out there. So let's say that limit equals L. If the limit L exists, then the sequence converges to L. We say those terms are converging to whatever that limit is. If the limit does not exist, then the sequence diverges. And we've come across those couple of words when we did improper integrals as well. So determine if the following sequences converge or diverge. If they converge, what is the value? All right. So conceptually or notationally, we are looking for the limit as n goes to infinity of this sequence, n over 1 minus 2n. Now sometimes we, as n is approaching infinity, I've stressed the importance of like which one dominates. Does the top dominate? Does the bottom dominate? Sometimes you can use horizontal asymptote rules as n goes out to infinity, things like that. There's, ways that we can evaluate this. Sometimes it's going to be helpful to just list the terms out and see what's happening. I'll show you that here in a little bit. But if you remember back to horizontal asymptote rules, if the degrees are the same on the top and the bottom, then as n goes to infinity, you're just going to get whatever that leading coefficient fraction is. In this case, 1 over -2. So -1/2. So visually, I didn't write this, so I don't have these listed out. But imagine I plug 1 in for n. I would get 1 over 1 minus 2. So I get -1. If I plug 2 in for n, I get 2 over -3, so -2/3. If I plug 3 in for n, I get 3 over 1 minus 6, so -3/5. If I plug 4 in, I get -4/7. And basically what this is saying is if we keep extending this sequence, then the terms are approaching -1/2. You're never going to get to -1/2, but the terms are converging towards -1/2 is what that is saying. Now look at b, and same thing. Let's take the limit as n goes to infinity of 3 plus -1 to the nth power. So this is one where we can't really use horizontal asymptotes. We don't have a rational function like a fraction, top and bottom. And so this might be one where let's just list out the sequence and see if that helps us. So the first term, if I plug 1 in, then I'm going to get 3 minus 1. So the first term's 2. And then I plug 2 in, and I get 3 plus 1, so 4. And then I plug 3 in, and I get 2 again. And then 4, and then 2, ... So you could see visually, without using horizontal asymptote rules or anything like that, like this sequence is not converging towards anything. It just alternates between 2 and 4. So we would say this sequence diverges. The limit does not exist. I should have said on this previous one, converges. I apologize. Let you down. Feel free to pause it and try C and D and see if you understand this concept, and then I'll kind of work through them, but that's up to you. So the next one, I'm going to take the limit as n goes to infinity of -1 to the n plus 1 over 3n plus 5. And I can already tell this is going to have that alternating, series scenario. If I list out those terms, if I plug 1 in, I get 1/8. If I plug 2 in, the next term would be -1/11. And then 1/14. The next one, yeah, I know, it's going to be -1/17. And then 1/20, and -1/23. And then it's going to be 1/26. Holy moly. And we could go on forever, So notice here that the top is always going to be 1 or -1, and the bottom is going to grow infinitely large. So even though these terms are alternating between positive, negative, like the fractions are getting closer and closer to 0. There's, think about plotting these points. They're going to kind of bounce back and forth, but always getting closer to 0. So we would say this converges to 0. And that's going to be a really important concept. I mentioned how we're going to have a bunch of tests to determine if a series converges or diverges. Well, even to have a chance for a series to converge, the terms of the sequence, if you would list them out, those are going to have to approach 0 to even have a chance for a series to converge. Like that's going to be the first thing we look for. We'll talk more about that. I'm getting ahead of myself. D. Ooh, big numbers. So we have the limit as n goes to infinity of 2 to the n over n to the whatever that number is. It's erroneous. And we have this topic of domination. Well, exponential functions are always going to dominate polynomial functions. The top is eventually going to get, significantly large compared to the bottom. So this is going to go to infinity. Diverges. And the last bit of the notes is taking the terms of a sequence and writing an expression for the nth term, basically writing the formula. I remember thinking back to Calc 2, I struggled with these. I remember winging it, and I think I did okay, but I remember these not coming very naturally to me because there's different things to look for. So this first one, is just some things I look for. First, I look for if it's an arithmetic sequence, like is it going up by the same number or down by the same number? Because if it is, you can turn that into like a linear formula. I notice this is going up by 4 every single time. So that means my rate of change is 4, like your slope is 4. And then I think to myself, if I would plug 1 in for n, I have to get 3 as my first term. So then what do I do to this? Well, I would have to subtract 1. So linear, constant rate of change, those are a little easier to think through. And you can double check it. If I plug 2 in for n, I should get 7, and I do. So there it is. I would encourage you on this one, definitely pause it and see if you can come up with formulas for the next two. Kind of fun to play around with the numbers and stuff. All right, welcome back. So, I look here and I just see, is it going up or down by the same amount? And it doesn't look like it. And then I look for some patterns. I notice on top that it goes 2, 4, 8, 16. Those are basically powers of 2. This is 2 to the first, this is 2 to the second, 2 cubed, 2 to the fourth. And so that tells me when I'm writing my formula that on top it's going to be 2 to the nth power. Because if n is 1, I get 2. If n is 2, I get 4. And so that's going to be the top part. And then I look on bottom, and let's see, I have 3, 5, 7, 9. Well, that takes me back to this first one when it was going up by the same amount each time. Well, this one's going up by 2 each time. So that means there must be a little formula to figure out what the denominator numbers are going to be. Well, it's going up by 2 each time, so 2n. And then if I plug 1 in, I have to get 3. So plus 1. And these are always kind of fun because they are self-checking. If you plug 1 in, you should get 2/3. If you plug 2 in, you should get 4/5. And, that way you just kind of play around with the numbers until you get that to happen. And there it is. And C. Well, let's see. First thing that jumps out at me is I notice it's an alternating sequence, positive, negative, positive, negative. So that tells me it's going to have that -1 effect. It's either -1 to the n plus 1, or it could be -1 to the n. And the way is you just look at the positive and the negative of the first term. So I know it's going to be -1 raised to one of them. Well, if the first one is positive, then that means if I would raise this to the nth power right here, well, that's going to give me a negative first term. So I'm going to start with n plus 1 right there. Now if I plug 1 in, I get +1. If I plug 2 in, I get -1, and so on. And then on bottom, well, I see there's a 1 on bottom here, a 4, a 9, a 16. Well, hot dog, those are our perfect squares. So, like this is 1 squared, 2 squared, 3 squared, 4 squared. So you're going to be taking n, whichever term number it is, and squaring it. That's it. We're going to be getting into series, and that's when the fun begins. So get excited. Let me know if you have any questions. Peace.